everyone, my name is Samuel Dembowitz, and today I'll be talking about Lab 2, Lines of Charge. In this video I will describe the real-life system of a piece of tape with some charge. I will create a computer model in GlowScript to model the system, and then I will compare the model to the observed system and describe the physics phenomena involved. The rules of this lab are very similar to Lab 1, demonstrate how neutral objects can give and receive charges. We utilize Coulomb's law to calculate the electric force of a point charge, and the Newton's second law to calculate the force of gravity, and we use the summation to determine the amount of charge on the pieces of tape. We use these two equations here to calculate the electric field from a line of charges and the electric force associated with it. The physical procedure for this lab was the same. Create a negatively charged tape, labeled tape B, which was achieved by quickly removing a piece that was on top of a base piece. We then placed tape B onto two books for support, and created another charged piece of tape, labeled tape A. We held tape A and tape B close to each other and noticed how tape B moved upward into this floating position. We recorded the distance between the two pieces of tape when this occurred. The physical system remained the same. We had a piece of charged tape that was 0.00025 kilograms, 0.25 meters long, and the charged tapes were separated by 0.02 meters. We calculated the force of gravity through this equation here, and we calculated the point charge by setting the force of gravity equal to the negative force of electricity, since we know that in the y direction the net force has to be 0. We then calculated the electric force to the point charge model, as you can see here. In order to make a proper GlowScript model, we had to take some assumptions. No air resistance, treat the pieces of tape as line charges, and assume that each piece of tape has the same amount of charge. We utilized the fact that both pieces of tape were negatively charged, which explains why they repelled, and we knew that the top piece was experiencing a gravitational force counteracting the electric force in the bottom piece of tape, as we can see in the summation that we used earlier. Here is the initialization of my GlowScript program, with the electric field constant, G, and the mass of the piece of tape. We also created the top tape and bottom tape charge objects. Here are some of the forces that were calculated in my model: the gravitational force, which was mass times gravity in the negative y-hat direction, and the electric charge that we used based on the summation Fnet equals Fg plus Fe equals 0, and this was iterated upon to make the model more accurate. And here is the electric field function here. This is for a point charge, and this is the integrated version for the line of charge, integral of dE. You can see the result of the GlowScript model here. Here are the results of the GlowScript model in a bit more detail. The magnitude of the gravitation force is 0.00245 newtons, and in order to make sure that the Fnet of the system is 0, in order to keep the piece of tape floating like we saw in real life, the charge on each piece of tape had to be 2.528 times 10 to the negative 8 coulombs. This made sure that the electric force is 0.00245 newtons, just like the gravitation force. And you can see in the diagram here that the white arrow represents the overall electric force, the yellow arrow represents the gravitation force, and that each of these green arrows represents a point charge electric field that we used over multiple point charges. You can see all of these red and blue circles here to represent the entire line of charge. The first discussion question had us look at the differences in the point charge model, which had a charge of 1.04 times 10 to the negative 8 coulombs, compared to the line charge model, which had 2.528 times 10 to the negative 8 coulombs. We notice that this is a 143% increase in charge magnitude from the point charge model to the line charge model. And these values differ because the line charge takes the electric field at infinitesimally small segments, all those small spheres that we saw on the diagram of the previous slide, to calculate the overall electric force as integral dE times Q, compared to the single point charge model, which assumes that all of the charge is in one single point rather than distributed on a line like the real-life system. The line charge model is more likely to be closer to reality since it makes fewer simplifying assumptions about the system, as I just mentioned, with the point charge being a single point compared to the real-life system being a line. Thank you very much for watching.